Start the video. All right. That's kind of how it is. All right, systems of equations. This is nothing new. This is nothing new. We saw this in 2A, Unit 2A, probably a month ago. It is the situation where you have a system, so these equations are related. We're going to look at them on the same graph, if you have to graph them, which is going to be an option for some of the problems. But looking back to 2A, this is how I taught it in 2A. Remember, we have Fruit Ridge, we have Stockton. And where do I have to put the cone for the complete intersection? In the middle. And would you say that if I put the intersection there, the cone right there, that cone is on Stockton, right? It's also what? On Fruit Ridge. What is in common is our solution. This is our solution. So when we are working on these problems, one thing we know is where they intersect is our solution. Okay. They may not intersect. If two lines are parallel, do they intersect? No. In Euclidean? Yes? No? They don't intersect. Okay. So if they don't intersect, we don't have a solution. Fruit Ridge and Florin, they never intersect. No solution for those. But we're going to look for, when we graph, we're looking for where they intersect. And when we solve algebraically, what you have to do for a couple problems, you're making them equal to each other and solving for x, plug it in, find your y, or vice versa. So main tool is to make the equations equal. Solve for x, then plug in to find your y. You can also graph to find the solutions, and I'll tell you which homework classwork you can do graphing with Desmos. But you see here, here's the one solution for this line and this quadratic. The two graphs intersect here, that's the only solution. Okay. So looking at these two problems, that's a good example one to start. With example one, let's use our primary tool, which is making them equal to each other. When we get to example two, we'll have to do something slightly different, but don't worry about it. The problems we end up with look exactly like, it's kind of a combination of what we did on Tuesday and Wednesday. Tuesday we had all these problems with fractions. Yesterday we had the roots that are involved now. So we can deal with this problem pretty easily. But I say before we do any strategies for those, let's see, can we simplify this or maybe do one step to make it just an easier problem? Does anybody see that? In fact, talk to your neighbor real quick, make sure they know. Make sure they know. What's the one thing you could do to make this problem a little easier? A little easier. All right, let's see what we know. 31 brains. What do our 31 brains say?
Subtract 2 from both sides.
Subtract what?
Subtract 2 from both sides.
I can't actually subtract 2 from both sides.
Let me subtract 2 from that side.
Yeah, but it's 2 times root x. I do like the idea of what you're doing, but it wouldn't be subtraction. It would be division. All right, everybody peek up here. What I can do first off is divide by 2 on both sides. Look what happens. What happens? Goodbye. Then? Goodbye. Root x is equal to 1 over x. Essentially, it's this. Now there's a bunch of things we can do. Or one thing. Or two things. What is the one thing you think we should do? Where's mine? What a weird video. My viewer in Brazil is going to be like, what? Okay, what's a Brazilian? What's Portuguese?
Mr. P.
For what? Now people are confused here. They're definitely confused in Brazil and Pakistan. This is a math.
Wait, so
This is life. We laugh. Yeah.
can we square it?
I like it. We could square it. We could.
To get rid of the...
Yeah, let's square it. Let's see what happens. Square both sides. What happens on the left? We know this from yesterday. Goodbye, goodbye. This is essentially 1 over x times 1 over x, so we have 1 over x squared. Now I want to get that out of the fraction. I don't want it down here, so what could I multiply this by to get the x squared out of there? It would also have to be multiplied on both sides of the equation. What do you say? I want to get this x squared out of the bottom. By multiply by. Ooh, Zeke. X squared.
Oh.
X squared. X to the third is equal to 1. Now the reason I put this here is because when you see the third power, don't be intimidated. We know if we had x squared is equal to 1, we would just square root. If we had x to the fourth is equal to 1, I'd do the fourth root. If I have x to the third is equal to 1, I do the cubic root. Third root is fine. Goodbye. X is 1. Cube root. Cube root. X is 1. But we're not done with the problem. What else do we need to do? Remember we're looking for? Intersection point.
Wait. Is that a 3 to?
That's a 3.
And then is that a square root? Wait, on the side.
So we're doing the third root.
Okay.
Because it's the third root. The third root of 1 is saying what times what times what gives you 1. 1 times 1 times 1 gives you 1. So remember though, our answer we're going to put here is 1 for x. What's for y? Now remember, the Stockton and Fruitridge, the cone is on both streets. So it doesn't matter what value for x or what equation I plug in my value for x. Which equation would be easiest to plug in? G of x, right? Oh, f of x, square root of 1 is 1 times 2. Here, if we plug it in here, it's 2 over 1. You see? When they're that simple of equations, doing a little mental math to get the other part of the point is fine. Now this one over here is going to be a little different. For the problems that you have to do for classwork, I think I'm going to make it where I want you to use algebra for numbers 2 and 4, and then the other ones I want you to graph, because those 2 and 4 are cumbersome. There's a lot to them. Let's look at the next one. All right, we're going to look at the next one. Oh, I'm so excited about math. Movements.
What's up, Mr. P's viewers? What's up, Mr.
All right, what's different? What's different with this one over here?
Welcome back to the video.
Good. Compared to that one over there, our first example had f of x, g of x. So first to talk about this. Who was confused about f of x and g of x? A little bit? Anybody? Okay, good. But just remember, this is function notation. Essentially, this is y is equal to 2 times root x. This is y is equal to 2 divided by x. This is just the function g, that's the function f. But since they're both a y term, we made them equal to each other. Over here, we don't have it set up where it's y is equal to. We have up here x is equal to y squared. So I'll give you 10 seconds just with your neighbor. What's the strategy over here then? What are we going to do over here? All right, who feels pretty confident? Pretty confident? Mel, what do you think?
X equals 4 minus x over 2 squared. Like that, the equation of y is squared, and that equals to x.
That is a very clever.
What did you have in mind?
Oh, no, I like this. It's very smart to think of it that way. But I want to go to the path of least resistance, if that's okay. I like that, though. I hadn't thought about that. Here's the deal. X is equal to y squared, right? X is equal to y squared. It's a system, so this x and that x are identical. So I could take the y squared and just put it right here. That's where I'm going to start. Y is equal to 4 minus y squared over 2. But I really like what you're saying. You're saying this. You're saying plug it in the other way.
Yeah.
Okay. Next, what do you think? This is over 1, that's over 1. So we're thinking of our Tuesday homework where we had to find the, and what is it? So remember, we don't find that in order to shift all the fractions. We're only finding that to multiply everything. We multiply everything by 2. Because it's an equation, you can multiply the left and right side of an equation by the same value and not change anything. You haven't changed the balance. The main idea of an equation is that the left and right are equal. So, looking at that, that allows us to what? Say goodbye to fractions. 2y is equal to 8 minus y squared. Who can tell me where this problem is going and why they know? There's a clue up there that tells us what kind of ending we're going to have to this problem. It's like the end game. You're playing chess. Beginning game, you set up your board. Mid game, all the battles. End game now. End game. How do you get the checkmate? Who sees the end game? Malaysia. Yeah. We're going to set this up as a quadratic. What was the clue?
Y squared.
Y squared. It is negative y squared, so that kind of tells me too. Which side should I move everything to? Left or right? Let's move it over. Good. Add y squared. Subtract 8. Add y squared. Subtract 8. Gone, gone. Nothing on the left can combine, so we just order it in descending order. Minus 8. You see where we're going? Anytime you see that squared, often we're going to factor it towards 2 binomials and get our answer quick. How quick?
I didn't mean for the last one, but the first part you got right.
Yeah.
But
Oh, like shooting an arrow.
I love you, teaching.
Our next method, what multiplies to give us negative 8?
4 negative 2.
And adds to give us 2. 4 negative 2 will work. You agree with that? So again, I hope you're starting to see it doesn't end in a bunch of different ways. If you have a quadratic, it's going to end like this. Let's see, x plus 4, x minus 2. So my two values for my x are going to be negative. Why did I just made a mistake? Why?
Because you get 0.
What are these? What are these?
Why?
Y's. We ended up finding y first, which doesn't matter. It doesn't matter. So I'm going to go ahead and put in negative 4. I'm going to put in 2. Does everyone see? Any questions on why I put those values in there?
So there are two solutions.
Yeah, they're from the y. Because it's this expression times this has to give us 0. So either this is 0 or that's 0. Y plus 4 is equal to 0. We solve, we get negative 4. The same for y minus 2. I'll write that out just for fun. You see, y is negative 2. You'll do the same thing for that other one. The other expression we also add 2 to both sides. That's how we get these. All right. Which one up there is easiest to plug in? Top one, purple. Yeah. Look, we put in y is equal to negative 4. Negative 4 squared? 2 squared?
4.
Let's double check they work in the other one. Negative 4 we put in for y. That's really 16 divided by 2 is 8. 4 minus 8, negative 4. Here we plug in 4 divided by 2. 4 minus 2 is 2. Got them. Answers. Okay. So I'm only going to ask you to do 2 problems like this. I'm going to ask you to use Desmos for the other ones. Remember, the intersection is just the solution. If you're just purely using Desmos, then I want you to make a graph sketch of each graph. Okay. All right. So what should we say to the viewers? Something with bacon in it. Oh, dang it. What should we say? We haven't done just a subscribe for a while.
Just because you're not eating bacon, don't be hating.
Don't be hating on bacon. Stay bacon.
Stay bacon. Stay bacon.
Stay.
Wait, no, that doesn't work.
How about off the skillet on 3?
Yes.
All right, off the skillet on 3. 1, 2, 3.
Off the skillet. Hashtag baconators.
Hashtag bacon. Don't be a hater.